Good afternoon, everyone. Thank you so much for joining us today on our panel titled Hydrail Technologies for and the Future of Rail Electrification Worldwide. We are all excited by the introduction of the Coradia iLint line in Europe and what it means for Hydrail technology worldwide as we move forward towards the adoption of hydrogen and additional zero-emission technologies. Our panel today is going to talk about the introduction of Hydrail to Europe and the need for a network of green hydrogen supply to support regional networks in the adoption of low-cost Hydrail technology towards the electrification of rail systems. We have a distinguished panel with us today. We have Rob Campbell, who is the Chief Commercial Officer at Ballard Power Systems. We have Bertram Ludwig, who is the Strategic Management Head of Strategic Management and Technology and R&D and Rail System and Technology at OBB in Austria. We have Christian Gerster, who is the VP and Head of Advanced Technology and Transportation at Bombardier. We do apologize. We seem to have been having some technical gremlins today, so we have a little bit of a late delayed start today, and we seem to have one of those gremlins with you as well, Rob. Unfortunately, we see you upside down. But hopefully we can work through that. We can see if our backend team can sort through that. While we give our backend team some time to sort through the camera on Rob's end, perhaps we can go through our second speaker, Bertram, and we can follow up with you. And Rob, if we're able to sort through that, we'll come back to you next. If not, we'll try to do this just audio and with your slide deck, and we'll roll through this. Thank you so much, everyone, for joining us. And we're going to move on to our first speaker today, which is Bertram at ABB. And we're just going to pull up your slide deck. And over to you, Bertram.
Good evening, everybody. This is Bertram Ludwig from ÖBB speaking. I'm working at ÖBB Holding. I'm responsible for strategic research and development at ÖBB. And I'm not sure if you can hear me, but because I can't see my picture moving. But it seems like you can hear me. Who is ÖBB? ÖBB is the Austrian Federal Railways of Austria. Austria is in the center of Europe, so it's quite a platform in the middle of the big corridor of railway in Europe. We have about 42,000 employees. We are the number one in per capita transport on rail. ÖBB is the second biggest freight operator in Europe and beyond. And already today is 73% of ÖBB's network is electrified. We are using 100% green electricity for this. We are operating our own barrages for that. And on ÖBB's infrastructure network, in Europe, we have this split between infrastructure and operators. We have 43 railway undertakings operating. We have an annual investment of more than 2.5 billion euros in infrastructure as well as vehicle. And we have a total network of about roughly almost 5,000 kilometers. But we are strongly connected with between even Asia, so China and Europe. So we are operating freight trains between China and Europe, as well as a very intense night jet system, night railway, night trains in Europe. So on this side, on this picture, you can actually see our a very large network going all over Europe in terms of passenger transport. And in here, you can see the countries where we are operating rail freight. But ÖBB, as I said before, 70% of our railway network is electrified already. ÖBB is not only a railway operator, but also the biggest bus operator in Europe, in Austria. We are about 3,500 buses operating, and we are searching for solutions in terms of buses. But we are mainly also searching for solutions in terms of railway. And therefore, we are searching especially for solutions on regional railway lines. We have actually a climate protection strategy until the year 2030. Our goal is actually to be CO2 emission neutral by the year of 2030. How do we want to achieve these goals? First of all, railway electrification. That's what we are working on. That's what we will increase. The goal will be by 2030, 80% of our network. We are searching for solutions in terms of bi-mode trains. So as you can see on the left picture, this red white train is actually a bi-mode train from Siemens. and which we have tested during the last years, and which has been actually quite successfully, and it works for up to 60 kilometers without using its pantograph. On the right, you can see a hydrogen train, because we're working on some research and development projects where we try actually to green shunting trains for our freight system, but as well as for our passenger transport. So we have a very, very high goal, 2030 to CO2 neutral in terms of mobility, and 2050 fully CO2 neutral. One of the tests we actually have carried out is a test of a temporary test of a hydrogen train. And we have been testing this train now from the 11th of September to the 26th of November. So there are still a few more days left. However, I do have some bad news I will tell you later on. However, we are testing these trains. You can see on the map of Austria here. We're testing these trains in the region south of Vienna. It's a very hilly region. It's an alpine area, actually, because until now, these trains have been mainly operated in the north of Germany, where it is flat. But it's the first time ever that these trains are operated on a hilly alpine area. So that the area where this has been operated is a track which is 130 kilometers. So battery vehicles are not an option. And we have tested one of the trains, and they operated daily up to 500 kilometers per day. But we have not only tested the train, but we have also used a temporary fueling station for hydrogen. So we prepared actually all of our garages for that, and the entire railway station. We are also, the Austrian Federal Railways is actually the first bigger railway undertaking a testing of hydrogen trains. As I mentioned before, we are testing these trains mainly in alpine areas, which are mainly currently powered by diesel lines. And it not only includes the train itself, but also includes the fueling station, maintenance of the train, and logistics. The goal actually is to gain knowledge about the train and to set actually to draw a path how we can achieve the goal of 2030 CO2 emission free. An interesting aspect of the train actually is that we have also applied for a full admission in Austria, and this train has now a full admission in Austria. The first results of this test have shown that the range is actually up to 500 kilometers per day. So that's a check for in terms of comparability to diesel trains. It's reliable. The fueling is easy and fast. We have a high certification among train drivers, customers, and we have full Austrian admission. But there are challenges ahead, such as the system change. It has a fleet impact. It has a technical knowledge is demanded, and we only want to use green hydrogen and green hydrogen production. And this is actually the biggest challenge we face currently in Europe. And I'm very eager to learn what you in Canada are doing, because we do not have enough green hydrogen at the moment. But however, we want to achieve the goal becoming in 2030 CO2 emission free. In case you want to have a look at our project, there you can actually also visit our website. It is in English, and in case you have any question, you can always contact me. Thanks a lot.
Thank you so much, Bertram. And it's been a while since I've seen you in Austria, but of course, last time we were there, we were discussing very clearly this great opportunity. And everybody, I think, is looking to this deployment that you just took us through the example in terms of how we can draw on that to go into the next round of potential demonstration in Canada. And that was the theme of a discussion earlier this morning that we had with Phil Gerster at Metrolink. So more to follow. We're going to come back to you in a moment's time because I think there's quite a lot of questions from audience participants about how we can deploy similarly these kinds of hydrogen rail vehicles in an environment and economy where, frankly, in Canada, we just don't have the same kind of population density around rail that even Austria and let alone Germany have. So more to follow on that, but it's a good problem to have, I would say, the one that you identified at the end in terms of green hydrogen, and I'll explain why later. So next, we're going to turn to our next panelist, Christian Gerster, who is the Vice President and Head of Advanced Technology and Transportation at Bombardier. As part of our national consultations, Bombardier hosted us at its Montreal facilities, where we were talking about lightweighting innovation. And of course, the Bombardier team was present at all of those consultations that fed into Transport Canada's report on the top 10 innovation projects in Canada. So Christian, we're delighted to have you here today, and I'll turn the virtual microphone over to you.
Thank you very much, Josipa. Good afternoon or good evening. Pleasure to play a bit the Diabolus, Advocatus Diaboli, probably tonight or this afternoon. Let me explain how we see the way forward in the next 5-10 years from a rail OEM manufacturing and strategy perspective, when we compare battery electric trains versus hydrogen fuel cell based trains. And starting with a short introduction, I will not talk too much about Bombardier Transportation, one of the bigger players as a rail OEM and also operator and maintainer. My background personally is in propulsion and brake systems, so a bit directly connected to the subject, and also formerly I've been managing the product management and engineering for the business unit locomotives. Going into the subject, I would like to start with a short comparison of all the alternative propulsion and electric propulsion being, I would say, the backbone of today's modern fleets in railway. But if we specifically look into battery electric and hydrogen fuel cells, we immediately see key differences when we compare a number of aspects from power generation over distribution to the vehicle, and resulting in different primary to wheel efficiencies. First point, where we see that electrified, for sure, a full electrified railway system has the highest energy efficiency from primary to wheel, wherever the primary energy is coming from. Technology readiness, fully there, fully established for all fully electrified, and even local emission and NOx is locally zero for electrified. If we compare to that as a reference, we see that battery electric trains are close to it when it comes to energy efficiency, close to it when it comes to technology readiness, and even in the environmental aspect with locally zero emission and for NOx and CO2. It has, even depending on the application conditions and degree of existing infrastructure, lower or slightly higher total cost of ownership, looking to the rolling stock. And typically infrastructure is at a similar range, like a kilometer electrified, comparing to charging stations, which battery electric trains might need. If we compare hydrogen on that very simplified level, we see immediately that the primary to wheel energy efficiency is much lower due to the multiple conversions and assuming to start from similar and hopefully green primary energy. Technology readiness is not fully there yet. What is similar is the zero emission aspect and characteristics, but then the cost and TCO for operating such trains is substantially higher. And I will go a bit deeper in the next slide on that. And that is clearly coming from the additional conversion, energy conversion steps from electric, assumed original electric, and then chemical and back to electric, which is reducing the energy efficiency by a factor of 3 to 4 overall. We also have considered, when we evaluated our strategy, other synthetic fuels and for combustion engines, but they are even less attractive from an environmental and energy perspective. So if we go a bit deeper and compare directly again, battery traction versus hydrogen hybrid, and that's what I mean with a reality check, we see substantial difference. Correctly mentioned that above 100 kilometer is very much depending whether it's feasible with battery traction as an autonomy range, depending on the available, on the topography, on the line characteristics. But you can for sure scale today battery traction up to 200 kilometer range. Hydrogen hybrid, much higher. We assume 600 to 800 kilometer, depending on the tank size, which allows typically to refuel not every day, but even only every second day. Typically, we would assume not automated, while the electrical recharging, even with today technology, is fully automatic. The big difference, I think, the second one is the fueling technology we are interested to learn about, and also how the related safety standards for a rail application will develop. The transport infrastructure is essential because it's contributing to the energy intensity and energy use for a hydrogen system. And all in all, it's resulting in a substantial higher TCO. We see a factor of 3 to 4, and CO2 for sure, depending on the primary energy quality. For that reason, and I'm going now to my last slide with content, we see catenary electrification as the most cost-efficient and even the greenest way of operating railway lines with more than 10 trains or similar per day. And we expect battery EMUs to cover typically 80% plus of the non-electrified network with selective recharging. We see a chance and an application for hydrogen fuel cell, but not immediately, but they might become cost competitive, but in particular under conditions where clean electrical energy or power is available in excess and at a very low cost. We see that limit or threshold around 5 euro cents per kilowatt hours, not more. And for sure, hydrogen requires new infrastructure and safety concept and some international standardization, one of the key challenges. The same is valid for recharging stations for battery traction. However, they are based on today's standards, evolving for charging of batteries. Last not least, I would say the difference is battery traction for a railway is real and available today, whether for new rolling stock or as upgrade, while hydrogen might become a niche, but has a way to go.
Thank you so much, Christian. That was very helpful. And so, given that the panel is entitled Hydrail, the future of rail electrification, sounds like you're saying Hydrail is not the future primarily of rail electrification. It's really battery-based, direct from grid electrification of rail, with Hydrail potentially having a place, non-obvious one right now, non-obvious ROI, and some very serious infrastructure and standardization issues at play. So we're going to come back to that because, of course, Bombardier is, a very key component of the rail manufacturing sector in Canada, and with the purchase of Bombardier by Alstom, that raising a lot of questions as to, well, what does the future of this rail manufacturer look like, and is this going to change at all? So we're going to come back to you, Christian. There's several questions already lining up for you and for yourself as a representative of Bombardier. With that, I'm going to turn to our third panelist, Rob Campbell. Now, Rob, I understand your camera has gotten a gremlin into it, so it looks like you're upside down, and we've never seen that before, but there's always a first time for everything. So Rob is, as an innovator, I won't take a screenshot and tweet it, or maybe I will, but you'll have good fun with it, as will I. So we're going to keep your audio on just because it's a little bit distracting to see you upside down, and hopefully we can sort that. And I understand it's not your camera that's upside down. There's some kind of communication between your camera and the platform. So we'll deal with your audio, but we know what you look like, Rob. So over to you. And just to introduce you, Rob, for those of you who aren't as familiar with Rob Campbell, who's Chief Commercial Officer at Ballard Power Systems Inc. And of course, Ballard has been one of our founding members for many years as we've been trying to motivate this industry on the bus side. But of course, here today, we're here to talk about rail. And I have to say, the picture that Christian just painted is very different from the picture that came up during our national consultations, where Hydrail was positioned as a possible short-term ROI opportunity. So Rob, we'll turn to you for that, and we're going to pull up your slides. Now, your video is off, but you can still control your slides. So we'll leave it to you to manage your presentation.
Perfect. Can you hear me okay? My sound is fine?
Yeah.
Okay,
we
great.
can hear you perfectly.
All right. Thanks so much, and I'll add a couple comments to my presentation about the perspective we have about where hydrogen fits into the grand scheme of things. But thank you again, Josepa. It's great to be here today as part of this panel, and very exciting to talk about how hydrogen fuel cells for rail is on track with zero emission sustainable solutions that will help us address both climate change and pollution issues. At Ballard, our vision is we deliver fuel cell power for a sustainable planet, and we are making great progress on delivering that vision. Now, just a quick word on Ballard. For those who are not familiar with Ballard, we've been totally focused on our vision for over 40 years. And Ballard is one of the few PEM, or proton exchange membrane manufacturers, that is fully vertically integrated. Ballard designs, builds, and tests proprietary core technology components, including the MEA, or membrane electrode assembly, catalysts, and bipolar plates, all of which are key components of the core of any fuel cell engine. We draw upon vast intellectual property from decades of R&D, combined with our extensive experience and know-how in the key areas of stack design, operations, production, systems integration, and field operational experience. We lead the market in our overall experience and are fully committed to the scale-up investments needed to transform our transportation industry to zero emission. And we are also lead the market in the key heavy-duty applications of bus, truck, rail, and marine, with increasingly attractive operational performance and economics. Now, let's focus on fuel cell powered rail. It is a reality, in my opinion. We have operational hydrogen trams in China. We are also supplying systems for the fuel cell version of the Siemens Mireo train for projects in Europe. And hot off the press this morning is an announcement by Siemens Energy for their first hydrogen train. The announcement is titled Deutsche Bahn and Siemens Enter the Hydrogen Age, with a project in the state of Baden-Württemberg in Germany. Very well done. We also have fuel cells in use with the UK Porterbrook hydrogen prototype train and are seeing strong interest for hydrogen-powered rail projects globally. These systems are powered by building blocks of 100 or 200 kilowatts, depending on the application. We leverage the designs coming out of our bus and truck applications in order to deliver volume economics, as well as proven, durable, and reliable performance to the rail sector. Products undergo specific rail tests in order to secure rail system homologation approvals. Our modeling and operational experience is showing attractive economics with the use of green hydrogen as the fuel, hydrogen that is generated by renewable energy resources for zero carbon impact. While this has been a relatively quick development, I can confidently say that fuel cell powered zero emission rail is safe, durable, reliable, and affordable. The key question that's highlighted is, where do we get the green hydrogen? And this is exactly where things are happening in Europe, and very exciting things at that. Europe is rapidly transitioning with strong support for a green recovery. It's been in the press almost weekly. Most countries in Europe now have their own hydrogen roadmap or strategy that they are implementing. Finland just announced theirs last week. Initial regional efforts will focus on applications that create significant demand for the use of green hydrogen, such as decarbonizing current industrial applications. Hydrogen use in steel and the production of ammonia are two examples. Rail is also ideal as the routes are defined and enables scaling of the fueling infrastructure required. But let's look further. In this next slide, what I'm showing here is the vision to link 10 European countries together with a network of hydrogen pipelines in order to connect large-scale green hydrogen production, even as far off as from Africa, Northern Africa, to demand. And with this pipeline network, we can provide secure and cost-effective supply. This initiative, known as the Hydrogen Backbone, is the collaborative effort of 11 leading European energy providers and shows how the overall plans for decarbonization are shaping up in Europe, providing a strong example for the rest of the world. So, green hydrogen will be available and economical. And this is also the conclusion of reports by McKinsey and recently published by the IEA. So this is independently validated. Of course, it takes time, it takes effort, but this is the clear direction. So where exactly are we? Europe leads with the adoption of hydrogen solutions for rail, and initial trials are quickly migrating to series production trains as the new zero-emission standard. As with any new technology, we need to practically interface with the codes and standards developed over decades for rail. We need a pragmatic approach to homologation, and this is what we have seen thus far with initial trains. We need to underpin this exercise with green hydrogen as referenced, and major commitments for this are happening in Europe. Now, this green hydrogen, it ties back to the total cost of ownership. It is the key input to total cost of ownership is the cost of this hydrogen. And when I reference these reports, the cost of hydrogen is plummeting in the forecast that we're seeing and is actually rapidly changing in the projects we're participating in. And the projection for green hydrogen is that it will be in the $2 a kilogram or less range by the end of this decade. And there are projections of close to $1 a kilogram within the next 20 years. So this changes the total perspective. And when we talk about TCO and economics, what we're concerned about is the cost per kilometer, the cost of the total system. And this is where, with the low-cost hydrogen, it actually makes sense. And finally, this is all part of a master plan to decarbonize our planet. And we all have an important role to play as our respective industry and government champions to drive positive change as soon as possible. Rail is very important and will be a first mover in this critical transformation. So let's all get on board for the new way to electrify and decarbonize with hydrogen-powered rail. Thank you.
Wow, thank you, Rob. So very different opinion put forward, which is exactly like what we like to have on these panels. So let's try to unpack this a little bit as the questions are coming in. We're going to start off first and foremost, Bertram, we're going to make your video live as well. If you don't mind enabling your video microphone, then we'll be able to see you. Rob, we're going to keep you just kind of neutral emoji there because you're going to flip around, but we'll see what we can do. In the meantime, we've got question. We're going to start off first, Rob, with yourself and Bertram, and then Christian, we're going to come over to you for the feedback on this. The question has to do with the Coradia iLint. I mean, everybody's looking at the Coradia iLint and saying, look, here's a demonstrator vehicle. It's been shown to prove itself out. It's been shown to be fairly effective. And so the question is, what are the large successes, if you were to name the top 1 or 2 successes of the Coradia iLint vehicle system? And then if you were to note the 1 or 2 bottlenecks that are problems, apart from the fuel supply, you know, where you get your fuel and hydrogen is the same problem as where you get your electricity from. If it comes from coal, it's no good, right? So we all know that. But outside of the fuel supply, like the electrons or the hydrogen source, what are the best successes of that Coradia iLint vehicle system, and what are the big bottlenecks from an innovation standpoint? Like, are we really looking at essentially what we had with the BC Whistler trial, first generation of hydrogen fuel cell buses? Or are we talking about something that's further along the commercialization pathway? So Rob, I'm going to turn to you first if you can summarize for participants top 2 successes and top 2 failures or bottlenecks of that project.
Thank you. Well, I think the first train is fantastic, and one of the key successes is public awareness. Public awareness that this is a safe, reliable, and achievable solution that can be brought to bear in the market. And with that, we open up our perspective and our minds to the possibility of applying this technology in a broad-based basis. In the fuel cell business, you know, I mentioned we've been in business for 40 years. We've never seen the interest we see today and the thirst for solutions in rail and all sectors. Basically, but it has to be underpinned by confidence that this is safe. And so I think one of the key aspects of the first project was it really reinforces that this technology can play an important role in decarbonization in a safe and reliable fashion. In terms of challenge, you know, being first is always a challenge. There is a need to move to series production, to scaling up the manufacturing in order to achieve the design integration that will lead to that attractive TCO. So I think the first trains are demonstrating the range, but we also have to iterate on our engineering side to ensure that the efficiency is there as well, so that that use of that green hydrogen is cost effective. So it's all part of a process of investing in the sector to deliver, much higher TRL technology readiness technology that will last 30 years. And this is what we're working on. We have a commitment to the sector, and we have designs that are based on that 30-year lifetime expectancy.
Well, and if we take an example of rail as just a heavier, more vested version of bus and transit, I mean, we know from our own experience that innovating standardized electric buses has taken over half a decade, and that's when everybody ran at it full throttle. So these things take time. They take multiple years. That doesn't mean that they're never solutions. So that's very good to hear, Rob. And the same gremlin that has attacked your camera has attacked Bertram's audio. So we're going to jump over to Christian and hear the alternative perspective, which is, so, there's a lot of cheerleading here. There's a lot of good news. There's a lot of excitement. There's hydrogen strategies emanating in Europe and in Canada. And the whole idea is, of course, longer range electrification without all the ongoing high power charging that has to happen if you don't have that range extender. So Christian, your ROI, your assessment showed that these just weren't the low cost solutions that lots of people wanted to have. And then, of course, the energy density is just not there necessarily, or the energy conversion is not as efficient as required. Can you take us through whether the big bottlenecks here are the price points? Was your modeling based on the Canadian landscape? Are there instances where Bombardier could see that ROI flipping in a shorter period of time than 20 years, but more like 5 years from now?
First, we have not modeled specifically Canadian tracks or emission profiles. We have looked at several typical in Europe. Some might be comparable. We have looked in particular, for example, in France for a number of cases with SNCF, where after heavy debates over years and a lot of promotion, at the end, the TCO-based investment decisions have been concluded to selectively electrify, to add limited sections of catenary to the existing rail network and to combine it with battery traction to replace diesel trains and to keep the system overall in the existing standards, but just it was a TCO driven. We see similar decisions taken in Norway recently with the same background. It's about TCO and system complexity. Not introducing hydrogen is one of the factors because it's an extra factor and difficult to combine with existing, in particular, electrified rail infrastructure. In all countries where we have partly electrified networks, and I think that's in most countries the case, we have the advantage with battery traction that it can be combined with existing electrified sections without adding extra elements, extra power supply or extra energy supply stations, while a hydrogen fuel cell train might operate all the time under hydrogen fuel cell because it's difficult to combine it. For sure, technically possible, but difficult to combine them in addition with an electrified catenary operation. So that's one of the advantages. It's all a question of the existing infrastructure. And the cases we see so far with going for hydrogen are niche islands. We see that in Austria, there is one such an operator, very pioneering, but we understand it's a niche case. It's in excess power production from hydropower. We see a bit similar in northern Sweden, and we might have similar cases and situations in Canada where indeed the hydropower in particular or any other green power is available at below 5 euro cents per kilowatt hours, and then it can make sense. And that's the same ambition with this network, which we have seen before from Rob's side, where Europe tries to find below 5 euro cents green electric power to produce the hydrogen in the Sahara region, for example. I think that critical criteria is this energy cost for a green electric power to generate the hydrogen from.
So two things, maybe, Christian, we're going to dive into that a little bit, and then Rob will ask you to come back in. And I know we have Bertram back on the line. We're just getting his video back up. But are we talking about potentially two very different things? So one, Christian, what you're referencing, when we look at the SNCF and others who look at TCO, they're looking at a fully commercial product, right? They're looking at, if we purchased this and procured this system and operated it like a fully commercialized service, would it match up? And the answer to that question is no. But if we're saying that it's not yet at that technology readiness level of 9, but it's down around the technology readiness level of 6, 7, maybe 5, 6, 7, and that's where the Coradia iLint is. And if we found a demonstrator track, that's really where we are. And so it's viable and feasible for demonstrator deployments. And if we don't do demonstrator deployments, we will never get to TRL 9, where the ROI magically makes itself happen. And part of that demonstrator, as we heard from our national consultations, was integrating, as you noted, in Ontario, there's surplus green energy. A lot of it is distributed, a lot of it's dissipated, some of it's sold off at a loss to the United States historically. So we know we have surplus green energy sources already. We have that potential for a TRL 5, 6, 7 demonstrator vehicle. Would that seem reasonable, Christian, in your view? Or is it sort of the industry has to figure out how to get to TRL 9 without any demonstrator support in between?
Used to a limited extent, you need this proof of concept type of demonstrators. I think the demonstration for the onboard design of trains is mostly done, where I think more to come is in the area of fueling stations, automation of fueling station related safety standards. In particular, if when this should be combined with electrical rail infrastructure. I think there are some specific challenges to which might take time, but I think that's where I would see more demonstrators and proof of concept and also standard development to be necessary and to come. And then I think, though, always back to the energy question is, what are the opportunity costs, or what are the opportunities you are missing? What else could you do with this excess energy if you have it, before you just use it to turn into a chemical and then back into an electrical power? But as soon as you have no other alternative, then it might be an absolute attractive way to go, clear.
On that front then, Bertram, we have you back, so that's great. What you've identified, Christian, is, okay, a demonstrator opportunity could work, but then, could you have used that hydrogen for another application that had other applications down the road? And then, of course, there's the standardization issue. And Christian, the point you raise is really apropos. We're facing the same thing on the bus side, because there will be fleets in Canada that cannot fully electrify, a lot of them with only battery electric buses, unless they have a lot of en route clustered high power charging. And so it's feasible to envisage that you could have hydrogen and high power electric buses in the same fleet in the future. And there's no standard for what happens when you have a high power DC charger next to a hydrogen storage tank. That just doesn't exist. So it's sort of throwing the dart in the dark. Now over to you, Bertram, on that point. And you missed a little bit of the earlier discussion, but essentially we're looking at the Coradia iLint, and loads of people are saying this is a great demonstrator. It proves out a lot about the powertrain, about the vehicle, about the rolling stock. Maybe it doesn't solve all the fueling side issues, but can you, speaking from the ground of experience there in your backyard, what are those top 2 benefits of that Coradia iLint project? And then what are the top 2 bottlenecks that need it to be a challenge to be replicated elsewhere?
Thanks a lot. As I mentioned during my presentation, we were actually testing also a battery vehicle, and it was interesting that these battery vehicles was only working for about up to 40 kilometers. So one of the great advantages actually of the Coradia iLint was that it operates up to 500 kilometers per day and in a very, very hilly area. So it's actually like it's a replacement of a diesel vehicle. So we were fully satisfied in terms of that. Still, there needs to be some work done in terms of reliability of the train. But however, we should not forget that these 2 trains which now exist are prototypes. So they will improve during the upcoming years. So I think this is very normal that you have some issues in the beginning. As I said during my presentation, also we had unfortunately last week a railway crossing accident. So I think this is like, but this has nothing to do with hydrogen. But unfortunately, this happens sometimes. As Rob said, I think one of the challenges remaining is actually the price for hydrogen. I think this is like the crucial point because if it remains too expensive, we won't use it. And in general, the production of green hydrogen, we won't use any. We won't switch to hydrogen trains if we do not have enough green hydrogen. And there is something else we really need to consider is it is a system decision. because as a railway operator, we cannot actually operate a variety of trains like diesel trains, electric trains, hydrogen trains, and hybrid trains, because that would actually also means that we would then need to have different knowledge. So you need actually to have more stuff, and you actually need to have different garages and workshops where you can actually work on these trains. So I think this is a very profound technical decision you need to take one day. And I actually also agree with what Christian said, and this is we should not forget that the main focus still lies on electrification of our network, because it is, in terms of efficiency, it's just the most efficient propulsion system. Yeah, I think it works. We are very happy. All our staff was very happy and very happy actually, the train drivers and so on. But the core question which remains is the price for hydrogen.
Okay, so let's come to that on the supply side. Oh, I'm just getting a bit of feedback, so I'm going to mute you, Bertram, but we'll unmute you in a moment. On the fuel supply side, so this is a long-standing issue we've raised over the last few years in Canada, and it exists in Europe, in European Union states as well, in Germany and Austria. Historically, our governments have divided at the federal or state or provincial level. We have divided transportation and energy ministries. So Ministry of Energy is over there doing its business, Ministry of Transportation is over there doing its business, and never have the two actually held hands and gotten married and gone on a honeymoon and come up with a whole family and progeny of children. And yet that is actually what has to happen now. We actually have to have a transportation energy strategy, a transportation energy matrix. Otherwise, you cannot get to zero emissions anything, because there either isn't enough supply, or there is enough supply, but not at the moment of time you need, whether it's direct electrons or it's electrons through hydrogen molecule into electrons again. And so the need there policy-wise for what all of you are speaking about is clean, green, low-cost hydrogen that can only come from an energy strategy by government. And so I'm going to start, Bertram, with you, and then go to you, Rob, given your experience in British Columbia and all the announcements being made there, and then Christian to yours, perhaps from a federal perspective, given that Bombardier offers and delivers vehicles across the rail network. What do we need from government in terms of an energy policy? Because if yourselves as transport operators are relying on manufacturers to deliver green hydrogen to you, it's not going to happen on their own. Rolling stock manufacturers don't make green hydrogen, and utilities don't usually partner with the Bombardiers of the world to come up with common strategies. So how does this have to happen? What is the policy that we need in order to make green, clean hydrogen for an ROI, or a total cost of ownership, that makes sense for hydrogen rail deployments in Canada or in Europe? Bertram, we'll start with you, because you do represent a public rail operator, and I have to say one of the best, I think, in the world, because it has the best coffee, and I only say that because I drink a lot of that coffee on the way to Zagreb. So over to you, Bertram, for what do we need from the energy policy side?
First of all, I do think that we are quite happy in Austria, because the Ministry of Energy and the Ministry of Transport is within one ministry, but that also actually leads to a lot of discussions. So that's why the ministry they insist actually that only green hydrogen will be accepted, and only local produced hydrogen will be accepted. I think what we do need is funding, and enough funding, sufficient funding to get the market started. I think this is crucial for the entire market. That's something we really do need, and we should not forget that with hydrogen it's more or less similar than with diesel. Like 150 years ago, diesel was like sold in pharmacies and places like this, and then we created an entire pipeline network all over the world, and now we are buying diesel from countries like Saudi Arabia and then sending it to Europe, which is actually quite strange that we do these things. But this is actually where we are right now with hydrogen, and we should actually go for this, and we should fully acknowledge that we are at the starting point, and that we need to invest into this technology to actually green our industry and our transport system. I think this is crucial, and to provide sufficient funding.
So there has to be a policy around investment into the energy supply chain on hydrogen, and a massive one at that. Rob, I'm going to turn to you. I mean, hydrogen, or your group has rather been at Ballard, and I should say Hydrogenics incumbents have been active in the area as well. But you've all been active in British Columbia, now in Alberta, in Ontario, and federally, getting some policies underway on the hydrogen fueling supply side. Can you take us through that? What has to happen there to make Hydrail even a possibility?
So I think you touched on it. I mean, it's basically, this is a complex problem we have, is to decarbonize, and it can't be siloed. It needs to be coordinated, and that takes strong leadership by the provincial and the federal government levels, and it takes a commitment to a goal to act, and act fast. In British Columbia, we've had tremendous issues with forest fires. It's part of the climate change initiative, impact. We saw the fires in California and the West Coast this year, in Australia over the beginning of the year. This is a reality. So that leadership needs to be a commitment to a goal, and consistent policy needs to be implemented that's coordinated across all the stakeholders. Funding assistance can help get us going, but I think it's more, having a level playing field so that one technology isn't disadvantaged to the other, that we all have the ability to contribute, and particularly that carbon-based energy assets are appropriately priced in terms of their long-term impact on the climate. So, and this, we think, will allow industry to do what it does best: to innovate, to apply, to move forward, and most importantly, to invest. I've been in hydrogen for like 20 years. I was in the electrolyzer business. There was no green hydrogen 10 years ago, 20 years ago. This is a new phenomena where the market actually says, I want something that's sustainable. I want something that's tied to renewable energy and that can actually enable greater use of renewable energy, because one of the challenges with wind or solar is its intermittency. Storage of hydrogen effectively deals with that intermittency issue. We just need more of it. Everybody wants it. And with strong policy, strong direction, Canada, we lead in renewable energy. We got hydroelectric, we got wind, we got solar. We can do it. It's just we need to start the first step of a long journey, but we got to get on this path as soon as possible.
Yeah, well, and it's why CUTRIC's been running a National Power Providers Working Group for the last 2 years, trying to get all our utilities from BC Hydro to Ontario Power Generation, Hydro One and Manitoba Hydro, everybody at the table to recognize that utilities need to have a transportation, specifically a heavy-duty transportation strategy by the end of next year in order to get to these zero emissions goals by 2025. So the points are well taken. Now, Christian, over to you in terms of the kind of fueling policies that are required to motivate this technology to bring down that total cost of ownership. Can you reflect on, from the manufacturer standpoint, what movements you see from a policy perspective that give you a sense that the hydrogen fueling policies are or are not there for the infrastructure deployments needed, and what you're seeing by comparison on battery electrification on that side of the equation, rather, from a policy standpoint? Because clearly Bombardier has to make investment decisions, and surely you're taking policy signals and making those decisions about the future.
Yeah, I think the fundamental difference I see is that the policies for electrification as a backbone of energy supply has been taken in all countries ages ago. So it's there, while for hydrogen it's something new to be introduced and the decision to be made. As you correctly say, it should be a joint energy supply, and in our case, transportation or mobility system is a system design choice. However, having given the fact that most or all countries and rail operators have partly or even largely electrified network available, it is an unfair or very uneven decision to take, whether introducing something new, where probably old infrastructure might somewhen get obsolete, versus enhancing with a partly new technology, which is the traction battery, which, by the way, is an enabling technology for the hydrogen trains as well. There is no hydrogen or fuel cell train running without efficient battery traction. It's just you need more batteries if you do it with catenary recharging. So I think it's an uneven competition between enhancing existing, mostly legacy infrastructure and the 100-year-plus old system decision taken in most countries for electrification versus replacing electrification or enhancing. But the issue I see personally is it's mostly a question either or. The combination, I think that would be changing the discussion heavily, but that requires on one hand technical solutions for handling hydrogen in an electrified railway environment, and also the safety standards and related rules and normative legislation foundation. I think that would change the decision, let's say, the black-white decision making, which at the moment a railway infrastructure operator would have to take either or into either and or invest into hydrogen, but not make the existing electric infrastructure obsolete.
That's very helpful, Christian. And just as a final question then, and unfortunately Bertram's video chopped out again, you might come back in just in time. You made a good segue. We had a couple questions from our colleague Nirmal at Canadian Nuclear Labs, and the question is one that we've heard many times, which is about overall the sustainability of these technologies. And we've asked it in other panels as well. Now, correct me if I'm wrong. I mean, as you just said, a hydrogen rail vehicle is very similar like a hydrogen electric bus in that they're actually battery electric vehicles. And they use the hydrogen fuel cell stack to feed into the battery matches the motors, and as a result, that's how you get propulsion. So it's not like they're fuel cell stack vehicles without energy storage on board. So they have the same problems that battery electric vehicles have, which is the waste problem associated with the batteries. But now they also have the supply of the hydrogen as an additional sustainability issue. Christian, I'm going to start with you. Can you take us through, as a final comment, on the sustainability of both the battery electric and the hydrogen fuel cell vehicles for rail in the future, compared to the issues that they face in waste management and all of those challenges that don't seem to have been addressed? And then Rob, we're going to end with you on that point.
I agree, they are not fully addressed when we look at the battery being an element for both type of trains. Anyhow, I think the key is in recycling, as in general for rail, as many other investment goods in the future. The cyclic approach is key. The question is how much can this be designed into the costing for TCO models, resulting in the right decisions. So how is the recyclability costed, and at what cost can batteries be recycled? We are reflecting that because none of today's traction battery technologies would last for a typical 30 years plus in horizon of where you calculate TCO and make decisions for rolling stock. So we assume in some cases might be 5 to 10 years, but a number of replacement. And this goes into the TCO models today and into how operators are evaluating commercial bids. That's important. I think that if policies can increase and help to accelerate to introduce a fully cyclic, full recycling, not only on batteries, but there is more materials, that will for sure be also a key element to drive to a full sustainability.
Thank you very much, Christian. That's very helpful in terms of the sustainability equations that have to go into the TCO calculations. Rob, over to you for the final word on what is the sustainability of these technologies and the calculations that have to go into them from your worldwide experience and how other jurisdictions are managing this stuff.
So it's a very big priority to get the sustainability right, and I agree. It's the recyclability of the technology that's important. This is one of the areas where fuel cell technology actually has advantages, in that the amount of material to be recycling is a fraction of what would be required with batteries. In fact, we design our products for full recycling already. We actually are operational today in recycling all of our products, and we reuse all the materials in our own products. So we capture all the catalysts, primarily platinum, and put it back to work in the new fuel cells. So it's something we've designed into our products, but it's much less an issue with fuel cells than the challenge with batteries, just because of the relative material concentrations applied, and the types of materials as well. We're not using the same materials. So totally agree. Sustainability through recycling programs is critical. It is a manageable process again, but it does require attention and effort.
And given that you have an energy generator on board, of course, one of the key components is we can reduce the size of the battery packs on the vehicles as a core component of sustainability. So with that, Rob, thank you. So, sorry, Rob, was there something you wanted to add there?
Oh, no, I was just agreeing. That's right. We all operate electrical systems, but when we hybridize the electric system with a fuel cell, the battery packs are much smaller.
Yeah, absolutely. So looking towards that optimized future, we're all on the same path towards electrification, or at least zero emissions, however we might get there. I really want to say thank you to Rob, yourself, Christian, Bertram, wherever you are in the digital ether. The gremlin got you, but we know that you're there intellectually and in spirit. So thank you very much for your contribution to the panel. And thank you to everybody here. I welcome you all to join our sponsor exhibit in a couple minutes by Parsons. That will be going live in just a couple minutes. Thank you again to all of you, and we look forward to a very innovative, bright future ahead in the next 10 years in rail.